That being said, we really won't be needing much in the way of doing any of this, your laptop this first lecture. Next lecture, if you have a laptop, bring it or borrow a laptop. I'll go into that, especially with the way the course is run. I apologize for going over the syllabus like this. I know it's boring as hell, but it does get longer every year, but that's primarily because of the fall freshmen. You see, fall freshmen are a mess. Spring freshmen, like a lot of you are, you're actually pretty good because you've already made mistakes. You've learned from the mistakes of being a fall freshman. So now you're here and you're an entire semester wiser, and believe it or not, that entire semester makes a huge difference. I kid you not, it is the amount of issues we get in fall because of just students, falling off the face of the earth or just having trouble adjusting to university is a lot. So, executive summary, and I will go into detail about more of these things. This course, I do try to do it in a flip fashion. Not nearly as much as my 2168 course, which is my GOAT. It is the best course. I love it. I love teaching 2168. I love this course too. I just love 2168 more. 2168 is basically CS3 if this is CS1. It's also because it's a smaller course and I actually get the time to actually meet individually with all the students, and that's really awesome. But this is flipped, meaning the idea here is that you read lectures, watch lectures, read the material each week before coming to class. And in class, rather than me droning on and on for most of the lectures, I do try to do practical exercises. Now, that being said, I sometimes assume that, hey, you may have missed the lecture, so I do repeat things. That you would have learned in the textbook. I introduce concepts as though it's the first time you're learning them, even though I may have done it in the lecture before, because some of these concepts can be difficult. So I'll go into more details to where you can find all of that information, and I'll remind you a few times throughout the semester. Labs are in person unless otherwise specified, right? Occasionally, if the TA is sick, worst case scenario, we might do that remotely, but in general, your labs will be in person. This was more important to have when things were transitioning from COVID. There's a Zoom link, a Discord link, and lecture recording. Zoom link for meeting me, if case I hold things virtually because of illness, or because you're meeting me for office hours, it's the same link. A Discord link, which I'll explain, and links to lecture recording. So Discord link first. I run a Discord server for not just this class, but all the classes I teach. It is populated by a lot of people who used to take my class. So it is a place to come in and ask questions. I've already seen a couple of you on there. It's great to ask short questions. It's also a great place to ask for help on assignments or exercises, or just simply to network or communicate with people. So part of this is also because I know a lot of you will probably in every class I've been in, I see students who set up a group me or something else, right? Part of this is just to kind of save you the trouble of trying to organize that and get into that chat. Also, I know it's a bit weird having a professor in the chat, but also it means that I can shut down anything if there's somebody trying to scam somebody else, right? Or starts posting very inappropriate stuff. I can shut that down. I have control over it. So that's part of it, and I'm there to answer. You can send me via email. You can send me messages via email, and I'll reply to you that way. If you send me a message via Discord, there's something about Discord messaging that allows me to be a lot more informal and just simply reply with a GIF or something. So I might do that. Finally, lecture recordings. You can find the lecture recordings for this linked from the syllabus. You can find them over here, right here in this button in the center that says lecture recordings. And finally, over here under other important links, I've got the same link repeated here, just to get you here. Now, this is a playlist of all last semester's recordings. And this is a playlist, right? So it's not one video, even though it looks like it. It is a embedded playlist. So you click over here, and you can select the lecture, or you can just go directly on YouTube. I host them on YouTube, not because I'm farming for advertising money or anything like that. In fact, I really couldn't give a damn if you liked and subscribed. I've turned off as much monetization as possible, and I recommend installing an ad blocker so you don't have any ads cropping up on YouTube, because I hate ads. No, the reason I put it on YouTube is because I know every single device you have can run YouTube. That's why I put it on YouTube. That it is, and if it's down, it isn't my fault, probably. So that's the reason there. But I do record all my lectures so that you can basically review them at your leisure. It helps with handling a lot of DRS accommodations, and it also means that if you're sick, you don't feel necessarily compelled to come to class in case you miss something horribly important. So, and if you forget where that is, feel free to email me and I will direct you, no judgment. It can sometimes be overwhelming with so many classes you're trying to juggle. Okay, so let's see. Where was my syllabus now? Did it back out because I clicked on something? Probably. Okay. All right. So turning in your homework is a two-part process. It is submitting and demoing. Some of you most of you have taken your lab already, and you will have seen how that works. Basically, you turn in your assignment, and you don't receive a grade until you show it to us. This can be done during my office hours, during the TA's office hours, during your lab, during a basically impromptu office hours where you email me or your TA or another TA to do this over Zoom or on a scheduled time when you can meet in person. Sometimes I'll have time after class to take demos. So, and you've got there's a nice window basically to demo it. It doesn't have to be demoed by the due date. You have weeks after the due date to demo your assignment. So there shouldn't feel like a rush. And if for some reason life happens and you can't demo it, just email me and and as extension on that. You just simply have to. I will periodically turn those, twice in the semester I'll basically be turning those into zeros, basically when midterm evals are due and when final grades are due. That's when I turn undemoed assignments into zeros. And in the case of midterm evals, often those can be corrected, right? Okay. You probably don't know where you probably looked for the textbook at some point. There isn't one to make you buy, because I hate textbooks. Or I hate paying for textbooks. We are going to use runestone.academy. We will be signing up for that on Thursday if you don't sign up beforehand. But it's a free textbook. You don't pay anything for it. Okay? The website will have some quirks, but that's worth the price of admission. And it involves things like being able to run code and execute your code in there. It's great. When you sign up, there's certain requirements for doing so. Not requirements, just things that make my life easier for when it comes time to import grades. Because it doesn't link directly with Canvas, I have to manually pull it in. Okay. Don't cheat. I'm pretty good at catching people. I've submitted a grand total of 56 charges since fall of 2021. Most of those were during COVID, where the temptation was just a bit too high for students, and they thought they could get away with it. And don't come to class if you're feeling sick, even on exam days. We will work with you to make it up. Don't try to demo everything at the end of the semester. It's just not going to happen. And finally, I will go over reasonable AI usage for this class. I am realistic about this kind of thing. It exists, is the tool, and I have a very nice and clear policy on it. But over-reliance on it and using it to do your assignment, which isn't good. I mean, yeah, you might be able to get by with the assignments, but you're going to absolutely get wrecked by the exams if you do that. Okay, so that being said, there are this is a new thing for the semester where we're experimenting this semester, which I call instant death or the instant failure achievement. There are basically 4 ways you can instantly fail the class. Failure to submit and demo lab 4 and 5, which is one lab. It's assigned in lab 4. And by week 8's deadline, as I'm calling it. So lab 4 and 5 will be due during week 6. Okay, its due date is week 6. So basically, if 2 weeks have passed since the deadline of Lab 4 and 5, at that point you have fallen too far behind in the class, is what I'm saying. Okay? So I'm not saying you have to turn it in on time. I'm saying you make sure you aren't 2 weeks late on that. The same thing is true of Hurricane Tracker. Hurricane Tracker, week 11 is where the exam happens on the subject matter that you had to master for Hurricane Tracker. So that's basically I'm saying, hey, you're 2 weeks late on this one. This is just because I kept seeing very bad students, or poorly performing students, I should say, who were coming to me in week 11 and hadn't gotten these things taken care of. And they were wondering how they could recover, and I'm like, maybe a time machine, I don't know. Uttering some variation of the phrase, I didn't know we need to demo our assignments to receive credit after the first exam. And then uttering some variation of phrase, I did not know I needed to meet with you and propose my final project after the final project, basically the week before the semester ends. So these are all things that those two things you basically have to not be showing up to class in order to happen, okay? And ever since I put that third clause in, it has not happened. It's been wonderful. I used to have that. I used to get at least like 3 students a semester out of like 100 telling me about that, giving me that, and now I don't. So that's 3 awkward conversations I don't have to have. All right. So sorry. It sounds like I'm being a bit of a hard ass. I promise you I'm not. Those are just simply, don't be super duper late on 2 big assignments. Okay. And if you are, just send me an email because again, I'm flexible. Okay. Okay, so this is the Intro to Programming course. It is for everybody. It does not matter if you have programming experience or not. It does not matter what your major is. It does not matter if this is your only computer science class or the one you are going to take to make sure you can take other computer science classes. I try to cater to every single person here, right? And I try to give you all enough knowledge so that it's going to be useful no matter what you do. That being said, it is a 4-hour course because of 3 lecture hours, 1 lab hour, as it's put. That means that, rule of thumb, you need to spend about 8 to 12 hours outside of class on this course in order to succeed. That's basically the rule of thumb is 2 to 3 hours per credit hour that you register for is the expected course load for a class. Now, the reason for this is that while, computer science is often compared to a math class, math courses, and part of this is because like word problems are probably the best analog we have for the types of problems we have to deal with. The best analog for kind of the effort you have to put in is a music class. So if you're a music major, or have done music instruments or been part of an ensemble, you have to basically practice in order to do your performance, in order to build up muscle memory, right? Especially if you've been in marching band or you know about all that you have to practice. You can't just simply do it all in one day, right? So it's just simply making sure you put in continual effort throughout the week as we do this. It is a skill-based course, and the only way to really to improve is to try and make mistakes and fail, and make more mistakes and fix those mistakes, and make yet more mistakes and fix those. It's an annoying process because you have to blame yourself for making mistakes, and that can be really damaging to your ego, but everybody does it, and in knowing that that's normal helps. So when you fall behind, the issue becomes you have less and less time to spend making those mistakes, right? So, okay. I have to put the time and place in my syllabus. I don't know why, since you all managed to find it without reading the syllabus. I mean, some of you did read the syllabus, so great. We have 4 lab sections, one of which is on Friday. Yes, it was weird having that Monday lab before the lectures. This will fix itself next week when we have Monday off. So then it will be Tuesday. So lab 2 will be during the Monday of the 3rd week, if that makes sense, right? So you're not missing the lab. This is the way it works every semester, okay? Where the second Monday's off. Prerequisites, some basic math. The most math that we will be using, okay. So the most math you will be using is basically, do you know the coordinate plane system? Okay, that's one. And then the other thing and then in week 5 we do go over something in week 3 we do go over something called the Madhava-Leibniz sequence, which because it has an Indian and English, British, German name, I don't know what Leibniz is. Anyway, because we've got a sequence named after someone, it automatically sounds complex. But really, all we're doing is basically doing a pattern that you'll be able to follow. You can put it in very scary mathematical symbols, but it's really not that scary. It's a pattern. So when I say really we just need a bit of math, for the first exam, you'll be drawing stuff at right angles. That's about it. And not too exact at that. So, all right. When you sign up for our textbook. Our textbook's on runestone.academy. You can log in. You'll need to create an account, right, for this. It's over here on sign up. When you log in, you'll create a username. I honestly don't care what it is. For your first and last name, put what's in Canvas, okay? And if you don't do that, at the very least, put in your TU email over here. Specifically, like mine is TUG85861, right? When you send me an email, you might be sending it to andrew.rosen@temple.edu. That's just an alias for this TU ID, right? For this, I want you to sign up for with this because that allows me to, when I run a Python script to combine my gradebooks, that allows me to match your name with in Runestone with your name on Canvas very easily. Okay, and then finally you'll have a course name to sign up for to get registered for my course. It is the extremely difficult and hard to remember for this semester Spring 2026 Rosen. Okay, so sign up for that one. I made sure to change all instances of Fall 2025 Rosen to Spring 2026. It's on the syllabus if you need it. It's also on the front of Canvas, so don't worry about it. It's right, like literally right over here with the instructions over here under the required course materials. If you don't do that today, guess what? We'll take 5 minutes at the beginning of next class to do that. Okay. Let's see. Got to keep more back. What I like about this textbook is once we are logged in, all right, my username is Prof. Rosen. Okay, once we're logged in, I have to adjust the due dates, I believe, here, but you'll come to this dashboard with a list of exercises and stuff, and you'll have these due dates for exercises. It may seem like a lot because I've given you everything in advance, but these are as I'll describe later, are soft deadlines, meaning these are when I want you to have them done. But if you don't have them done by this point, literally no biggie. That way you don't have to worry about doing all the exercises. I specify which exercises from the textbook I want you to work on. Okay? If you click over here, though, you can hit the entirety of the textbook and see what we need. We are not going over the entirety of the textbook, fortunately. It's like the first 10 chapters plus selections from chapter 12 and chapter 14. The main reason I like this textbook are the projects, right? The projects, and then also because we have code that can be run inside the textbook. Like over here, I can run this bit of turtle code, which we'll be learning right here in the textbook. No need to boot up your own Python interpreter to do that, or for some reason you are traveling without a laptop but really need to study, you can just lob it. As long as you've got access to a web browser, you can do your coding. Okay? So it's very nice over there. And then if you just need to do freeform coding, there's just a open editor right over here. There's more features that I'll describe, but it's very nice. It's got a lot of features that, paying $100+ on for a paper book won't have. Okay. So, if you do need a paper book, though, and you really learn that way, I have 2 suggestions for you, which can be bought for $20 to $30 hard copy. Both very good material. And also are free online. But some people learn better by just reading on paper, and so I just want to cater to that. Okay, office hours. The these are hours, hopefully you know by now, office hours means these are times where I make myself available to students, and the students are my top priority. Yes, I might be working on something else. You should still interrupt me because I'm just waiting for students at that point. I'm not going to sit around twiddling my thumbs. I'm probably going to, actually be doing something. My office hours are from 12:30 to 1:30 on Tuesday and Thursday. If you just need to drop in, but I am available to meet over Zoom or possibly even before the class in person. On Zoom, I'm available pretty much most nights. The only time you really can say I'm not going to be available is from sundown Friday to sundown Saturday. And I'm available pretty much most of the day on Sunday if you need to meet over Zoom. Saturday night's okay. Friday during the day is okay. Thursday, Tuesday, Wednesday evenings are okay. I can meet with you very late and have done so. Okay? There is free peer tutoring available for this class in room 358. It's listed there. Okay? Attendance, I'm not really going to be, I'm not going to bother even trying to take attendance for my classes. It just doesn't work out. And again, you're adults. If you have to miss class for some reason, I'm going to presume that you have actual things that you didn't get taken care of, and that you made a very conscious and important decision as opposed to just simply slacking off, right? So I assume since you're paying for the course, you want to be here. If you do arrive late, just, don't make a commotion. And I do, even though I'm recording my lectures, please attend because correlation is between attendance and performance is very, very strong. That being said, if you're sick, GTFO, I don't want to see you. If you are sick, I just stay home and catch up on the recording. Send me an email. This applies even if it's an exam day. Okay, if you are sick during the exam on the day of the exam is meant to be an assessment of your skill level. I cannot accurately assess your skill level if you are snotty and fogged up. It is not exactly the best representation. You will then arrange to take it with the TA at a later date. If for some reason that extends even for an even longer period for really serious health reasons, let me know, and so that we can accommodate, right? So you can make up your exam if you need to. We also have 3 exams and a final. That's a lot. But I dropped the lowest of those three midterm grades. That's also so that in case we do have an illness issue where a student isn't able to make up the exam in a reasonable time, that's not going to penalize them. Okay. Besides physical illness, I do care about about any mental illness. So I understand things can get really tough. Every semester, things seem to get crazier and crazier. So if you are having issues with worry, stress, problem eating, sleeping, whether because it's my fault or some other thing, just please reach out. I'm not a psychologist. I'm not a therapist. I'm not even going to play one on TV. I am but I can listen to you, and I can direct you to resources that you need. I can give friendly recommendations. And also, the sooner you tell me that bad things are happening, the sooner I can adjust things on my end to make things less stressful for you, okay? So, if things have happened and now you are housing's insecure, right? That is probably something I should know so I can adjust my expectations and possibly even adjust the schedule for you, okay? The schedule at which you turn in stuff. Okay, if you're telling me that you were, having issues with housing for 2 months, 2 weeks before the semester's over, there's not really too much I can do at that point, right? I need you to reach out. The sooner you reach out, the more I can do for you. Okay. Disabilities. If you have an accommodation need, please let me know via DRS. Most of these are typically accommodations for my lecture notes. I don't have any. You get my lecture recordings. And then the other ones are for extended time on tests or a quiet place on tests, which is through DRS. Okay. And I showed off my recordings already. A reliable laptop is recommended. If you cannot afford a laptop, please see me. I will help you find one in a budget. Believe it or not, $450, $500 will still get you a laptop that can pull its weight through most of college for you. You might have to make a sacrifice somewhere. That sacrifice is typically either on the side of weight or on the side of being able to use your screen easily outside. That is typically the trade-off you have to make. But performance-wise, laptops are great these days. That being said, you should probably get a new laptop if you have like keys missing in your keyboard, or you need to or one of your keys doesn't work in such a way that you have to literally copy paste the letter B in order to type correctly. Which, if it is a frustrating experience to use your laptop, it will be a frustrating experience in this class. You will suffer physically, emotionally, academically, wailing, gnashing of teeth, tormenting of soul, any kind of biblical term you want. It's just not a fun experience if you cannot use your laptop. Please talk to me. I love tech. I love being able to give suggestions. And I do have a very limited supply of laptops I can lend out to students, like my own personal stock. There are also laptops you can borrow from the university in kiosks, like down the hall to the engineering building or over in the library, right? You can borrow those for 4 hours while you're on campus. Okay, so we have tons and tons of resources. All the computers on campus. There's tons of resources. And you've got me again to answer these questions. So I didn't do my homework for 3 weeks because I didn't have a computer. That hurts me in the soul. It just really does hurt. Okay. If you are having issues with technology and stuff, and reach out, and especially reach out if you want my help. Okay. I will be using Zoom for majority of one-on-one meetings, but I primarily use Zoom when I'm sick or something happens that I need to stay home. This is also usually due to illness, right? All right. Grading. There is a curve at the end. It does not hurt students. If you get a 90 or above, you're guaranteed an A, not an A minus. B, 80. 70 is generally the minimum requirement for passing the class. The way the curve works later on is once we get to the 90, I kind of look at, 89.9, there's not really a big difference between that and the 90. 89.7, so on and so forth. And I just look for a gap in the grades where it can kind of draw a dividing line and say, there's an obvious gap between these two scores. And I say basically everybody above that gap gets an A minus. Make sense? And then the people who were below that gap, they get the B plus, if they were close, or they were close to a gap. And so I just look for these gaps. I found it to be a very fair way to do this, and consistently this gap is somewhere in the 88, 87 range. Okay. So, generally speaking, if you put in the effort and do everything and try to do stuff, even if you do terribly on all the things, but you tried to do everything, you're going to get a D. That is my rubric for F's last semester were cheating or basically having a 0 in any single of the grade categories, right? So not doing any of the in-class exercises or not doing any of the assignments, right? And below a 70 at that point, below a 60. So you had to really not participate in order to get Fs, okay? All right, so I break it down like this. Solo exercises, 10%, classroom exercises, 5%, labs, which are your typical, which correspond mostly to this is what corresponds most directly to your homeworks, 25%. A final project, yes, it's a freshman course with a final project, 10%. And exams are 30%, and the final exam, I guess best way to put this is midterms are 30% of your grade. There's 3 midterms, but we dropped the lowest, so that means that you will have 2 midterms, each worth 15% of your grade. And then the final exam is 20% of your grade. The final exam will consist of 7 questions. You get to choose 5 of them. Your choice. Also, you may not have to take the final exam. More on that in a bit. So first, I have basically 3 tiers of deadlines: soft, firm, and hard deadlines. Soft deadlines are things like the solo exercises and the classroom exercises. This portion, this 15% of the grade. These are things where I just care that they get done. If you miss the due date, there is no penalty. Okay? As long as it's done by the end of the semester, you get credit for it. Okay? Solo exercises. These are the readings and the exercises I assign in the Runestone textbook. They are fairly short. They're targeted. I shouldn't have to help you with them, but there are a couple problems that are tricky because the way they're auto-graded via unit tests, and sometimes your assumptions may be different than the assumptions of the person who graded that, or my assumptions in case I graded that. So if you do reach out, if you find yourself spending more than 15 minutes on a single exercise, stop. Something has gone horribly wrong. It's probably not your fault. Come and speak to me and we'll work on it together, okay? So I don't want you to waste too much time on these solo exercises, okay? These are soft due lines. Basically the due dates are saying, hey, have this read by or done by this time to be prepared for class to keep consistent with the schedule, okay? If you need to catch up, just catch up. You're not going to be penalized for it. Same thing with the classroom exercises. Those will also be drawn mostly from the textbook, right? If for some reason you have to miss class that day, you just simply watch the recording and follow along with that and do the exercise as well. They involve active learning. They will typically be the primary focus of our lecture, and they're intended to be completely done by the end of the lecture, right? So not only that, the way it typically works is that I give the problem, I give you time to work on it, not necessarily enough time to finish it because just because of the flow of the lecture. And then but even starting working on it is good. And then I will give basically the answer of that portion, and then we'll move on to the next portion. Make sense? So we're going to be kind of building this step by step together, and I'm giving you time to think on each step. Okay? You can work with your classmates on the solo exercises and the classroom exercises, even turn in the exact same stuff as your classmate, because again, this is the kind of stuff where I'm not really caring about that too much. It is just making sure that that you're getting this done and following along. Okay. So lab assignments, they've got a firm deadline, meaning that yes, there's a penalty for them being late. It's a very light penalty as compared to other classes. It is 5 points off per day late. That's it. So turn it in 4 days late, that's 20 points off. We also cap that loss at 50 points or 50% of the grade. So pretty much if you really fall behind in the class, you can still, or you skip an assignment and just get overwhelmed and can't turn it in on a timely manner, but can go back and do it later, you can still get half credit for it, okay? Because I'd rather you go, and the reason for this is I'd rather give you a reason to do these late assignments because you need the practice in order to learn, right? It's all about incentives for catching up, okay? You should be able to expect one a week. Some of these assignments are more work than others, and they have a correspondingly longer time frame and value of points. Occasionally, you'll be given the choice of assignments to do, like saying, hey, we've got a pair of assignments here if you're feeling comfortable with the material, or if you're feeling less comfortable with the material, okay? More importantly, what distinguishes these assignments is that you have to demo them, right? Turn it in, submit it on Canvas, and then show it to us, and then check it off. You'll learn how this really works over the next couple weeks. I write here in the syllabus that we have 2 weeks after the due date to demo your lab, but otherwise we'll enter a 0, but we can waive this. And the reason I have this is just simply so I can say no to a student who comes in at the end of the semester trying to demo everything. I used to entertain that from a student who would beg for, please, I need to demo these so I can pass the class. And it never went well, and the final straw was when the student couldn't connect and share a screen over Zoom. So he pulled up Zoom on his phone, and I got treated to his shirtless body. And then he went and pointed the camera at the screen so I could look his code. It was just a mess in every shape or form. That was probably the final straw for me being trying to be nice, because I said it never works out, and it didn't work out. A lot of his code didn't work. All right. turning in the lab. I explained how to do it, but it's writing down to here. If you're having problem with the lab or the assignments or anything in this class, it is literally my job to answer your questions. So please do not feel free to reach out to me or the TA. Furthermore, there are 4 TAs here. You do not just have to communicate with your TA or go to your TA's office hours. The TAs have scattered office hours so that if your TA's hours don't work for you, you can go to another TA's. And all the TAs are good. How do I know? Because I've worked with all of them before. Well, one's his first time with me, but he was a former student of mine. So every single student has taken, every single one of your TAs is an undergrad who has taken this class before and got an A in it. So 3 of them have been my TA for multiple semesters now. So they are all handpicked by me. All right. Final project. So last month of class, April, will not have any additional homework. Once we get there, all the homework's gone. I'm pretty much, there's just nothing else to really, because I could go in a lot of different directions. Computer science is a huge field, and I could go and teach about sorting and searching and common algorithms, give a big introduction to big O notation and binary arithmetic. But honestly, I find it more interesting to lecture about the topics I find interesting, and more importantly, to find out what you find interesting. The final project is worth 10% of your grade. It is the focus of the last bit of class. You basically get to choose whatever the heck you want to do. A lot of people choose games. A number of people choose to make bots. A number of people choose physical things. Some people make hardware stuff. It is incredible what we see, and I have an entire list of best projects that I keep from semester to semester. It is basically the entire point of the final project essentially is to throw you into the deep end of the pool so you actually realize you know how to swim. Okay? That's the entire point of it. And as former students will tell you, an A for effort in this is actually very achievable on the final project, where basically I see, hey, you learned a lot of stuff. No, you weren't able to complete your initial vision. It's a bit of a mess, but I can see you learn stuff along the way. An A, as in a 90 out of 100. And that's perfectly, that's the vast majority of the grades, 90s on this. Okay? It is a lot of fun. You can do it in any language you choose, right? Any programming language you care about. And as you know, it's great. You're also allowed to choose whether you want to do this as a group project or not, because we all know how group projects can go at this point, right? It can be a mess. And because it can be a mess, there is a max size limit for group projects, which is 3 members. If you have a 4-person group, congratulations, you've just figured out that you now need to decide how you're going to split up your 2-person groups. Okay, so because once you get to 4 people, you're going to get at least 1 person not doing anything. Okay, we have basically 4 different checkpoints on the final project, which is that we do a brainstorming session and teach you how to use GitHub, where you will be learning to turn it in. Then we have what I call proposal day, which is the proposal, which is what you tell me what you're going to do, and I make sure it's reasonable, not too hard, not too soft, not too hard, not too easy. Okay. I generally, the way that works is that I do that lecture over Zoom, because I spend the entire lecture basically meeting with one student after another and saying yes, no, and then when the student is done proposing, you can leave. So no need to drag you all the way to campus or make you stay in this room if you just need to meet with me for a few minutes there. Then a couple weeks before the project is due, we do a progress report, which may be just simply saying, oh crap, I didn't realize, I completely forgot about this and was busy, now I have to work on it. But simply put, having your progress report just simply as a wake-up call or to hear what you're doing on it. And then your final project is due on the very last day of classes, that very last Monday of the semester before the final exam starts. I make it due as late as possible for a reason. It is a very hard deadline, as some students found out last semester. I don't give, there is no turning it in late. And if you do, there is actually very very harsh deadline penalty for it. It is 0.1% off per minute late. That means that if it's an hour late, it's 6 points off. So, so if you turn in late, a couple minutes, I'm probably going to completely ignore that. But a couple hours late, it's going to be harsh. This was a case of students turning it in a couple days late. You turn in what you have, even if it's a mess, because believe it or not, I will judge that mess very leniently if I see that you learn things. Okay, you turn in what you have. Okay, that due date is not altered without prior approval. Prior approval being the big deal there, right? You gotta, if basically things are happening and you're having a legitimate around trouble or something like that, not legitimate, I'm trying, extreme amount, I should say. There are things, the kind of things that we would be considering an incomplete. That's when we're kind of talking about it, okay? Obviously, health issues, if you're incapacitated and unable to communicate for some reason, that's an entirely different story. But I have yet to come up with I've yet to have a serious reason for a student to turn it in late. And the couple times where I've allowed the student to turn it in late, I didn't do that last semester, but semesters prior to that, I have been so disappointed in what gets turned in. Okay. But, again, it's about the journey, not the destination. We'll go over more about this later, but it is a learning experience, not a tech startup. Okay. It's meant to be fun. It is meant to basically say, oh, I can do this. There's probably a number of you in this class who are seniors or juniors or getting very close to, or in your capstone. One of the things this is for you, I do allow you to double dip. This is typically explicitly disallowed by the academic policy without prior approval from your professors. This is approval from one of your professors. You can double dip your final project, meaning you can turn in the same thing for me and your other class, provided you can incorporate coding into it, right? So this especially helps the engineering students out if they're doing their something with microcontrollers, or you're working in a bio lab or something like that. So if you have, but even if you're working as a music major, I've had students write plugins, like guitar distortion plugins and stuff for their final project. It's been a lot of fun. Or I've had one student write something in Max MSP. It was a lot of fun. So I see one student nodding at that, so that's fun. All right. So you just simply also have to get permission from your other professor to do it. And I have yet to see a professor say no. They love it. Okay? So, right, again, deadlines, yeah. I'm lenient with basically every deadline except that one, okay? And here's the reason. I need time to consider whether or not your project's the best project. And remember how I said you may not need to take the final? I tried to select around 15%. It's been 15%, was higher last semester, of the projects that I find to be the best projects. And those students who receive best projects, they get to skip the final exam in my class. They're excused. So that's your incentive for doing more than the bare minimum. Okay, your incentive for doing more than the bare minimum is that you get to skip the final exam. It's nice not having to worry about that. Okay? Now, midterm exams, again, hard due dates on those, but if you have to miss that due to illness, just let me know, and we can make that up a bit later. Importantly, our first exams are going to be during your lab during your 6th lab. So let's go ahead and figure that out right now. Your first exam, so let's see. Week 1, 2, 3, 4, 5, 6. So your first exam will be if you're on the Friday lab, Friday the 20th or Monday the 23rd of February. That is your first exam. So that is typically when we do this. the reason, and that will be covering basically up through for loops and turtles. So you're allowed, that will be done on paper. You'll be allowed a cheat sheet. That cheat sheet can be done front and back. I'll go over this in detail, but it's any size cheat sheet you want, so long as it doesn't interfere with the student next to you, and you can do it handwritten or typed, I don't care. The important thing here is that preparing for the exam, preparing that cheat sheet is actually a lot more important than actually having it with you, I find. Okay. Same thing for the final exam. Final exam details, they say I have to put the schedule, the time and date on that is. I don't. I mean, I'm supposed to, but I don't. The reason being is that you can find it at the final exam over here, and I'll send this Temple final exam schedule, right? Exam schedule over here, and you'll get a PDF for spring 2026, and you'll be able to look up on, and this is the table that you'll be able to tell for every class. Even though our lecture is a 4-hour class, you want to check over here under the 3 hours. So we're Tuesday, Thursday, so it's going to be 4:30 from 1 to 3. So the 30th of April from 1 to 3. So pretty early on and during the semester. That's like the second day, which is pretty nice. Yeah, I know that seems like, oh, we don't get a lot of time to study. It also means you're not exhausted, which is what happens when it's the last day. So I'll go over more detail about that when we get there later. Right. So, okay, academic honesty. Don't cheat. I know that seems obvious, but let me. Basically, you should probably have an idea about what's cheating and what's not now. But for this class, since it's a new subject for a lot of you, I'm going to be a bit more explicit about that. Now, how do we deal with AI in this course? Because, we've got things like Google advertising stuff like anti-gravity, which is this wonderful VS Code fork, which has, it's built in connection with Google's coding engine, which is great if you know how to code already. And it can actually do a lot for you if you don't know how to code. I mean, these tools exist. I'm not going to stick my hand in the sand and pretend that they don't. But the key here is that what's a reasonable use in this course? I have this framework that I blatantly stole from Harvard CS50 course about this. And this was written prior to AI, okay? Primarily about how you interact with other people and what's okay to do with other people. And that's what I'm going to treat ChatGPT as and other things as. If it's okay to do with another person, another human being, then it's okay to do with an AI. If it's not okay to do with another person, then it's not okay to ask an AI to do it. Does that make sense? So let's go ahead and be more explicit about these things. What are the things we care about? Rule of thumb. So first off, I want you to collaborate. I want you to ask other people for help. I want you to work with other people because I firmly believe that the way to master the material is to teach it to another person. Okay? Rule of thumb is that if you are the one who needs help, you can show your code to other people. If you have a completed answer, completed work, you don't show it to other people. That's the rule of thumb. Okay? So reasonable. Communicating with classmates about the assignments or to understand the course material better. Please do that. Please ask people for help. Helping a classmate identify a bug in their code in person or online by, looking at, compiling that code, running that code, even on their own computer. Yes, please. Help out your other students. Right? Sending students your code. Possibly classmates so they can help you fix a bug. Great. Provided you cite that work, that's really good. I worked with Alice Awesomeface, right? She helped me with this. Okay? But as you're the person needing help, so sending your code to somebody because you need help, that's perfectly fine. Finding a few lines of code online because the docs have the documentation for this has code in it and suggests on how to do things. That's perfectly fine. When in doubt, cite the code. Cite where you got it from. example, looking out how to print the characters of a dictionary in numerical order on Stack Overflow as part of a larger lab, copying the 1 to 3 lines, and then citing that link. How do you cite it? We write something called a comment, which is basically one line, and you just simply drop me the link, the URL. That's it. None of this, no MLA, no bibliography there. Just simply give me a link to where you found it. That's really it. Okay. Speaking of Stack Overflow and other stuff, sharing a few lines of your code online so others can help you identify or fix a bug. Perfectly reasonable to go to an AI and say, hey, what's gone wrong here? Because a lot of the time it may just be you misspelled that word. You'd be surprised how often that happens in the beginning. Okay? Turning to the web or elsewhere to get more practice, great. In fact, one of the things I suggest you do with the AI is I give you practice exams. You need more practice? Upload my exam to an AI. Ask it to generate more questions. You should do that for a lot of your classes. Okay? It's a reasonable use of AI there. Okay? Whiteboarding solutions to problem sets. Literally writing it down, not writing out stuff and figuring out stuff, not on a keyboard, but on paper, pen and paper, or on a whiteboard or a blackboard. Those are fine. Great way to do it. Getting a tutor. Of course you can. Right? As long as they're not doing your work for you. What's unreasonable? Accessing the solution to some problems before you submit your own. In other words, basically asking Bad Barry, can I please see your code? And Bad Barry says, yes, here's all my code. Right? You don't want to do that. Asking, not citing where you found the material. Giving or showing a classmate a solution to a problem when it is he or she and not you that are struggling to solve it. Again, if you're not having any issues, there's no need to share your code. Okay? Right? Soliciting online for help to solve the entirety of the problem set for you. Splitting up the workload. Right, saying, hey, I'm going to do these 5 problems, you do these other 5 problems, right? And then combining that. That's not allowed. Getting somebody's answer and modifying it. And then finally, submitting the same or similar work to this course that you've submitted to another course or will submit to another without approval, right? That's just simply for the final project. Again, like if you need... There's rules against double dipping for classes. Just simply get permission in advance. Okay. So again, we can kind of really see about these things. Importantly, I have this thing called the regret clause. Basically, I recognize that sometimes we get stressed out and we make dumb decisions. The younger you are, the easier it is to make dumb decisions. It's just science. The brain still needs time to mature. It's not great at evaluating risk versus reward, right? So regret clause, if you mess up, and like this has happened, where basically a student was taking their final exam and they looked at another student's paper and copied down the answer, right? If you basically come to me and you confess within 72 hours, right, I will impose local sanctions, possibly limited local sanctions that may be unsatisfactory or failing for that portion of the work, but there will not be an academic misconduct thing. I get this about once a semester where a student triggers this clause and they reach out to me and they say something. In the case of that student who cheated on the exam, on that question on the exam, I just simply marked that question as a 0 and moved on. That was it. We sometimes make poor judgment, but owning up to it's important, right? So, let's see. So, disclaimer, I might switch the syllabus. You have rights. And most importantly, using AI for programming in Python has certain tells. I will go over those syntactic tells later. We can very easily tell, but based on the way AI decides to do things and format things. And we will call you out on that early in the semester if you're over reliant on AI. Later on in the semester, we might, If we've told you to knock it off a few times and you don't, that's when we'll escalate to academic dishonesty. But even if we somehow don't catch you, if you're relying on AI to do your work for you, you will not be able to do it on the exam on paper when the time comes. We'll be able to say, it's really strange that you did so well on the exam and so well on your assignments, but not well on the exam. Okay. And there's more to it than not being a bad test taker. All right, with that, we're going to do a bit of a history lesson for the remaining time we have in class. All right, so we are going to go over here, GitHub, teaching, intro. Okay, bit of a history lesson here. I haven't rewritten this in a while. So first, I should probably define what the heck I'm teaching here, because computer science is a terrible name for what we actually do here, because it makes it sound like we study computers, but that'd be like calling, as they say in this quote over here, chemistry beaker science, or astronomy telescope science, or biology microscope science. It's not that. It's not the study of computers. It's not necessarily programming, although computer science being programming is an extremely understandable misconception, that's a word, because our first exposure to computer science is typically coding. It's super understandable to think that's what it is. And if you do computer science, that does mean you can code, because it's an essential part of what it is these days. It isn't necessarily about learning a specific programming language or application. One of the things you'll learn by the time you get to week 10, it's going to be very easy for you to pick up another programming language. It's not like learning German and then having to learn French. It's more like having to learn, it's more like having to learn one dialect of English versus another dialect of English. It's much closer to basically saying, hey, American English versus some forms of English that maybe been localized in, say, Africa. Okay, or French versus colonial French. So we have those kind of differences. They're minor in syntax. They aren't major differences. Okay. So we can easily define what computer science isn't, and I find the best not wrong definition for computer science is the study of algorithms. It asks the question of what, when we get right down to it, can be automated. It is studying automated problem solving. So we'll get into what in the world is an algorithm in a bit, but it is a science, and it asks how can we do problem solving, and that's part of the reason I love it, because it lets me spend time looking at puzzles and games and saying I'm working, because I get to look at these kind of fun things. Theoretical computer science. So computer science itself is huge. Theoretical computer science, the really abstract kind of stuff, it covers a whole lot of things. And that's just the very theoretical part of it. Computational complexity, cryptography, information theory, machine learning, computational geometry, computational economics. There's a lot of things you can do with computer science. So what does this mean? We study the behavior of algorithms to see if they're correct. We design computer systems to execute algorithms. We design programming languages to implement algorithms. And we identify problems to solve and try to figure out, and this one's actually a bit of a doozy, can we actually solve these problems? So, more importantly, since we have a lot of non-majors, I do like to cover this section to tell you kind of the interdisciplinary stuff in computer science, because that's very important. Because once you know a lot of programming, it can do, or a little bit of programming can do a lot for you. There was one time when I was attending a conference as a master's student in Arizona. It was a distributed computation, and I ended up at the same table as one of the head researchers at Intel. And one of the things that he said that stuck with me was that he said it's a lot easier to turn a person with a PhD in biology into a good programmer than it was to take somebody with a PhD in computer science and turn them into a good biologist, right? It's very easy to, so in other words, just knowing a little bit was kind of his point. You could do a lot with it as a extreme specialist. And we are extreme specialists in our own way. But the reason I bring up biology is because the one aspect that is never, ever, 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 ever going to go out of style with computers is bioinformatics. It will be big. It will be big until the end of time because people keep getting sick for some reason. I don't know. It's like our body breaks down or something. Cancer detection, designing new medicine. That's bioinformatics. Calculating HIV inhibitors. Bioinformatics. Prosthetics. Bionics. In other words, can we build a better human hand? Or at least a appropriate replacement? Can we build things that, prosthetic eyes that people can see again? Better cochlear implants. Can we get it so that we can replace that darn muscle in our chest that keeps our blood flowing? These are really big questions. Hard questions. And that gets, forget about the more abstract ones of can we do like digital downloads of our brain, which are more sci-fi stuff. Like, can we fix parts that are broken in our body? These would require programming and engineering. These are big problems that are invested heavily in. And, you know, this is the cross-section between chemistry, biology, and medicine. Bioinformatics. Okay? If you're more physics or astronomy focused, quantum computing, supernova detection, sifting through astronomical data. There's lots of stuff that go important questions in physics and modeling in physics that need computer science these days. Engineering, so much programming of microcontrollers and hardware there. Being able to do stuff at the low level. Business and economics. If you really, really want to go where the money is. Okay, yes, everybody has that dream of tech startups. Well, not everybody. I certainly don't. But like that's kind of the meme of tech startups and hoping to be bought out by Google or some other big corporation. The real money is here. Working in business or economics, working for the banks in high-speed trading algorithms. Most trading is not done by people getting on Robinhood and spending money here. That's how most money is lost. Money is made by high-speed trading algorithms reacting to the market as fast as possible, which is definitely faster than humanly possible. Now, if you're coming from psychology, there's an entire field dedicated to that cross-section called human-computer interaction. And it deals with some obvious things like why doing blue on a black screen is a terrible idea, or maybe you should design your UI like this. Some darker things like how can we design our UI to extract as much money as possible from people, but also like how can we make computers as easy to use. I got my start in research in an HCI lab learning about how can we get humans who cannot see to use computers better. How can we make educational technology for students who struggle at math if they are visually impaired? Okay? Education. Edutainment is big. Always been big. Basically making educational software. There's more direct applications, of course, such as software engineering, network, data analysis, and, of course, security. For those of you who are interested, what is data science versus computer science? Data science, the one-sentence definition of that, it is the continuation of statistics through computer science. It's being able to basically do the entire chain of data analysis, from gathering the data, analyzing it, and presenting it. So let's talk about algorithms. What the heck is an algorithm? It's a weird word, but that's because it comes from a name. Okay, it is the Latinized name of Muhammad ibn Musa al-Khwarizmi. I probably butchered his name, but is a Persian mathematician, and we can blame him for a lot of your agony in life. Okay, he wrote a book called The Concise Book of Calculation by Reduction in the year of 820, and the first and we get the term algebra from that title, algebair, meaning reduction. That's right, he wrote the first book on algebra. You see, he noticed that these were these new, really nifty digits that the Indians were using that were base 10. And you could do a lot of calculations way easier in them. And so he wrote a book on how to do that. That book got translated and adopted by the Europe. So it got translated into Latin and transported to Europe in the 1100s. His name got Latinized into algorithmity, and that's where we get the term algorithm from. Okay? So, right, if we want to look him up on Wikipedia, that's not where I meant to go, but whatever. Etymology. Here you go. During the Islamic Golden Age. So notable work, Al-Jaber. Right? So he did a lot of stuff in his life. And it is pretty cool dude. Okay? All things considered. Okay? So what is an algorithm formally? It is a set of well-ordered, unambiguous operation that yields some result in a finite amount of time. That is a bit of a mouthful of a definition, right? Let's go through it. It's just simply very specific words to describe very specific things. So an algorithm is well-ordered. That means that we have a defined order, a beginning and an end. We do things in a very, very specific order, right? And more importantly, those orders say we do this first, and this one next, then this operation next, then this operation next. Unambiguous operations. You've probably seen like there's always this fun video that passes around on the internet every so often of basically an elementary school teacher asking her students, how do you make a peanut butter and jelly sandwich? Give me all the instructions. And then she mechanically follows those directions, leading to hilarity where she basically completely destroys the bread or gets peanut butter everywhere, or like goes and because they didn't define, you have to use a knife to get the peanut butter, she goes and scoops out the peanut butter with her hands, This kind of defining, hey, those algorithms, and the entire point is that we need these things to be unambiguous. If you're going to be grabbing something, we need to know specifically how you're going to be doing it. So well-ordered, meaning that there's a specific sequence. Unambiguous, you're not going to be able to misinterpret it. Operations, it yields some result. It does something. It does something. In a finite amount of time, meaning it does something eventually. It's going to eventually give us an answer. Okay? An example of an algorithm that you've probably used in real life is any good baking recipe. Now, you may have cooked, and doing stuff on a grill. That can be a bit more ambiguous. Baking, though, if anybody who does a lot of baking can tell you, baking can be very exacting. Leave it in for 1 minute too long, and everything goes wrong. Baking is its own thing. But that's the thing. You do when you bake, or cook, you have a specific order, right? You turn on the oven first, you preheat, you mix things in a certain order, you put it in the oven for a defined amount of time, you take it out, let it rest, maybe do some more stuff, right? So other algorithms you may have used is simple addition, right? Let's go ahead. 3-digit, basic addition like this, where I put numbers like this, 587 plus, let's go with 258. I don't really care what the numbers are, but you've learned how to do this and are probably already mentally starting to do it yourself, which is you line them up and you say, we start at the ones digit and we add these together. We put the ones place of the answer over here and put the carry over here. Then we add the carry in those 2 digits. And so on and so forth, giving us 4, carry of 1, and then 1 plus 5, 6, 7, 8. Right? This is an algorithm. It has specific steps. You go from the ones place to the tens place to the hundreds place until there's no more places to do. Right? You write down the ones. If your answer is more than 10, you put down the ones place. Sorry, if it's 10 or more, you put down the ones place, and you put down the tens place as a carry. Right? long division, an algorithm. Euclid's algorithm, which you may or may not have done, is an algorithm. Algorithms, once we make them into a program, that automates tasks for us. Now, let's see, skip ahead. Now, because I've only got 10 minutes left, let's talk about very, very brief history of computers and computational devices. The first kind of computational device that we really have on hand is abacuses, which are not computers. At that point, we're just, it's just extra data storage for us. It's kind of any kind of system for writing down stuff, using beads to calculate things. We needed to operate things to operate step by step. Basically, for a while, for the longest time, we really did not have a way to kind of automatically compute things. The human needed to be involved somewhere. We would use various devices to help us write down stuff or store data in some way, shape, or form. But not really any kind of machine. But we didn't really have any machines until like the 16 to 1800s, where multiple people kind of had the idea of, why don't we build a machine made of gears, clockwork kind of stuff, and we can turn the machine, or it can turn itself, right? And the position of those gears will represent the numbers. Multiple people came up with that. Pascal, Leibniz. Charles Babbage is probably the important one we care about here. He wanted to create a gear-based machine, and rather than going around and looking at the individual gears to figure out what it was, he's like, why can't I be lazy and just have that print out the answer on paper for me, right? So that gives us to our first programmer. First programmer, Augusta Ada King, the Countess of Lovelace, so she's often cited as the first programmer, often called Ada Lovelace. She is the daughter, and she would have, it's possibly funnier that she's more famous than her father at this point. Her father being the Lord Byron, the person who came up with the idea of the Byronic hero, which you may have learned about in world literature. He was quite the interesting fellow, a bit of a rock star of the literature world, and that was important when basically your entertainment of those kind of things were literature and plays and that kind of stuff. His divorce with his wife was so contentious for the period that people were arguing about it multiple years after both of them were deceased. Anyway, because of his hot-bloodedness and so to speak, Ada's mother directed her towards more of the sciences. And so she started learning a lot of the sciences and became a very adept at this. And the reason she's considered the first programmer is that she collaborated a bit with Charles Babbage. The idea here is that he created this analytical engine, the one I told you about this, or he designed it. Okay? And so what she did is that she had a paper that was on this, and she translated it. But then she also added her own notes to the translation of the paper, including, and this was a paper on this engine. She published the paper with her translation with her own notes. And those notes showed how you could use those gears to compute what are called Bernoulli numbers, which are important numbers in statistics. And so this was possibly the first program this is probably one of the first programs we've ever seen. Now, it is quite possible that, and this happens all the time in mathematics, that some guy in India came up with the idea hundreds of years before, and then that data was just lost or corrupted or never written down. This is the first earliest kind of thing we have where it's written down. It's more to understand how fragile data was until just recently. So easy for things to be lost and destroyed forever. Okay? Not just because people wouldn't just write stuff down, but because paper rots. It's paper. It can be exposed to the elements. Disasters happen. Fires, floods. Okay? So it's very easy. So there's tons of scientific discoveries that we've seen throughout history where they've just been lost to time and only rediscovered, or things get discovered independently in multiple places. But what really made Ada kind of ahead of her time was the idea here that she figured out that the analytical engine could be used to write things, to compute things other than numbers. The next big jump, it was to World War II. Ada Lovelace, unfortunately, she died at a very early age due to pancreatic cancer, I think in her 30s or so. World War II gives us the birth of modern cryptography. Codes got to the point where they were so complex we needed machines to not just make them, but also to break them. Alan Turing was one of the leader of the project at Bletchley Park that would work at decrypting Nazi communications. That was codenamed Ultra, the intelligence gained from them. So Eisenhower basically said that it was a decisive to an Allied victory. Estimates say it probably ended the year that intelligence, from breaking Nazi communications, ended the war 2 years earlier. It's also it's very interesting how these things worked. The idea here is that you had these complex things, and it's very hard to work and figure out what these encryption messages are going to say. But if you know what some of it is going to say, then it suddenly becomes a lot easier. For instance, the Germans loved to end their messages with Heil Hitler for some reason, so they knew what the last message, like the last 10 letters of any message would be for the day. So very easy to decrypt that bit. You had a crib to work with, so to speak. Your first computer is a bit... Anyway, Turing is considered the father of computer science. Alan Turing came up with the theory of computation, a whole lot of stuff. The proof of... Unfortunately, he died at an early age as well. This time a bit more direct. He was homosexual at a time where it was illegal to be homosexual. He was gay when it wasn't okay to be gay. The government found out and basically offered him the choice between chemical castration or jail. He chose chemical castration and then died of suicide following that. The government of Britain apologized for his death years later. And on that note, there's really no way to nicely transition from that to the other one, but it's important to mention that. The first computer, is a bit contentious. There's no clear first. A famous early computer is here, ENIAC, which was used for artillery calculations. And with the amount of time I have left, I'm going to talk about one last person. Rear Admiral Grace Hopper. Might as well give it the full title there. Grace Hopper, or as one person called her when she saw all her credentials, "What are you?" Because she is the woman who is the highest ranked woman ever in the U.S. military. Rear Admiral Grace Hopper. She also created. She was the first to devise the theory of machine-independent programming languages. She helped develop Flowmatic and COBOL. One of the first programmers on the Harvard Mark computer. She has a PhD. She is basically basically a complete badass. My personal favorite is this. She can be attributed to the first computer bug, which was a literal bug in a computer found in one of the vacuum tubes. Why was it not working? Why was the program not working? Because there was a literal bug in the relay. Moth in relay 70 panel, which is the first case of a computer bug ever being found. That is why we call these issues we have with computers sometimes bugs in our program, because it literally was at one point. These computers were pretty massive enough that bugs can get in. And the continuing dialogue of computers and computer science has been getting smaller and getting more. Computers have gotten smaller and smaller, and data centers have gotten bigger and bigger and more powerful. I see that I am out of time, so I am going to go ahead and leave it there. I'll be sticking around for a bit. If you want to come and speak with me, I will be uploading these lectures later tonight. Thank you, and I look forward to seeing you all on Thursday.